Okay, good morning, good afternoon, and good evening to everyone, and welcome back to our online tutorials. Today I just want us to look at an emphasis on limits and continuity, but more specifically on limits. I'm sure this video just focus more on limits. I'm sure most of us have an idea of what limits are, but basically I'll briefly explain from the definition, and then we'll be able to solve your worksheet 10 of BS 140, the last year 2024 academic year. So we're looking at limits. So limits, this is something as an introduction to calculus. Just as I simply said last time, calculus is basically divided into two parts. There is the differential calculus and there is the integral calculus. So in explaining the differential part, we always start first of all by understanding the intro, which is called limits. I'm sure limits in a simple term, if you look at limits, we're just talking about us basically approaching a certain value of x, and we'll be able to look at what the whole function basically approaches. So in understanding limits, we're trying to define a limit as, if let's say I let L be a real number, if you let L be a real number and f of x be defined in an open interval, where a point A exists. So a point A. So this A is basically a point which exists in a certain open interval where f of x is defined. So if I let L be a real number and f of x be defined in an open interval where point A exists, then we simply say that the limit as x approaches this point A. Remember, this point A is contained in a certain open interval. That open interval f of x that's where f of x is defined. So we are simply writing this as the limit as x approaches A in the function f of x. So what is happening here? The limit as x approaches A is the point in this interval. So this whole limit is basically equal to a real number L, which we have defined there. So what does this mean here? In simple terms, we are simply saying that as x approaches a point A, the function f of x approaches a real number L. This is what we are simply saying. So by approaching, we're not necessarily saying that we are at the point A, but we are simply trying to explain the concept that x is drawing closer and closer and closer to L. So the more x is drawing closer to L, the more the function f of x is simply drawing closer and nearer to what? To L. So x is coming closer to A, and the whole function f of x is coming closer to L. So basically what is happening here is that, remember, x is the input value. Whatsoever you insert at in f of x here, the x value, what are we going to have? We are going to have the whole limit. And the whole function f of x approaching a certain real number L. So in other terms, in simple version, we are just simply saying that finding the limit is just as good as evaluating f of x at that point. So we have to understand that finding the limit is as good as evaluating evaluating f of x at a. This implies that the limit as x approaches a of f of x is just as good as evaluating the function at what? At a. This is what we are trying to say. So every time we are drawing nearer to the value a, the whole function f of x will draw nearer to evaluation of f of a. This is what we are going to have. So the definition of a limit is in that manner. So L is a real number, f of x is defined in an open interval. In that open interval, there exists a value a where x approaches. So if x approaches that value a, the whole function f of x will approach a real number L. So put it in a situation whereby if, let's say, someone is in town, so we're trying to draw nearer to that person who is in town, or we're just trying to draw closer to town. It means that we are not necessarily going to reach town, but we're trying to move closer and closer to town. So as we are moving closer and closer to town, there is a certain thing we are going to find there in town. Maybe it's that particular person standing who we are looking for in town. So this is the limit representing what we are looking for in town as we are drawing closer to what? To town. Okay, so now let's look at some of these questions. So definition, understand it very well. Then from there, we have to understand that these limits, we can be able to find the limits at a point. So number one, some of the things you have to understand. Some of the conditions you need to know. So some of the conditions you have to understand is that number one, if you are looking for the limit as x approaches a of f of x, and then it happens that that limit is equal to a 0 over 0, then we are simply saying that this should not be your solution. This should not be your solution. So every time you have a 0 over 0, this should not be your solution because this is an indeterminate form. This is an indeterminate form of limits. So hence, it should never be part of your solution. So instead, if you have a 0 over 0, then proceed to number one, simplify your function. If it is not simplifying your function, you can simplify your function by factorizing. You can simplify your function by rationalizing. So if it comes out to be a 0 over 0, then stop and go and proceed either of the following. Simplify your function, factorizing your function, or rationalizing your function, depending on what is going to work out at that particular case. So 0 over 0 should never be your solution. Secondly, if you are finding the limit as x approaches a certain value a of f of x, just be able to know that such a limit, if such a limit gives you a 0 over c, then the limit is 0. So every time you have a 0 over c, it can be maybe you are evaluating the limit and then the out comes out to maybe 0 over 4 or 0 over 5, 0 over 1, 0 over 2, 0 over c is representing a constant value. So every time you have such cases, then the limit is a 0. But if we have the limit as x approaches a of f of x, then this limit gives you, let's say, c over 0. Remember, 0 should never be in the denominator. So this c should be something which is a constant value. If it is 0 over 0, it's an indeterminate form. But if it is c over 0, then the limit does not exist. Does not exist. So these are the three things you have to understand when it comes to a limit at a point. So the three things which you are supposed to understand when it comes to a limit at a point. Now, let's look at some of the questions in your worksheet. So let's look at some of the questions in your worksheet. So we're going to use all this information which we have written down. So let's look at some of the questions in your worksheet. So we have that we're going to have find the limit of the following, or we can say evaluate. Evaluate the limits of the following. So we are given that number 1, limit as x approaches 1 of the natural log of 6x power 5 plus 3x power 4 plus 2x squared minus 10. What is the limit as x approaches 1 in this particular situation? So remember, finding the limit at a certain particular point, it is just as good as what? Evaluating the function at x equal to 1. Isn't it? That's what we just mentioned in the definition. Finding the limit is just as good as evaluating the function at x equal to 1. So this will just be the same as, since this is a natural log function, so the limit will just go inside, since we're trying to evaluate this whole function at x equal to 1. So if as x is approaching 1, the whole function will approach f of 1. This is what we're trying to look at. So putting the limit inside, this is just as good as the natural log of, open bracket, the limit as x approaches 1 of 6 that x power 4 plus 2x squared minus 10. Then putting in the limit, this will just be as good as the natural log of 6 1 power 5 plus 3 1 power 4 plus 2 1 power 2 minus 10. As good as that. And then if we evaluate everything, this will be the natural log of, open bracket, this is a 6, this is plus 3 plus 2 minus 10. So that we can have the natural log of, this is a 9 plus 2 11, 11 minus 10, that's a 1. And the natural log of 1 means it's what? A 0. So what does this mean? As x approaches 1, f of x approaches what? 0. This is what we mean. So the more we draw nearer and nearer to 1 in the x values, the y values will be drawing closer and closer to what? To 0. Remember, this is a function x comma 1, obviously to have the domain set and the range set. So as you are looking for coordinates, even with your graph, this graph is this graph was sketched. As we are trying to locate x equal to 1 in that function, the y values will be approaching a 0. So if x is equal to 1, then we are trying to approach x equal to 1. Then the whole function f of x will approach what? Will approach a 0. That's what we mean. The same is happening to the second one. The same is happening to the second one. So the second one says that the limit as x approaches 3 of the natural log of 3 minus x over root of 3 minus root of x, close. So this is the same as the limit goes inside, so that the natural log of the limit as x approaches 3 of 3 minus x over root of 3 minus root of x. Something like that. So that we can have the natural log of, now when you are looking for the limit as x approaches 3, it is as good as evaluating this whole function at x equal to 3. So let's put in 3. What are we going to have? We are going to have a 3 minus 3 over root 3 minus root 3. And what am I going to have inside there? I'm going to have a 0 over 0. Now, remember what we said in the instructions? We simply said that 0 over 0 should never be a what? A solution. So, this is something which we are calling to be an indeterminate form. Indeterminate form of limits. So, what do I do? If it is a 0 over 0, you have to go back. It is either you factorize or you rationalize or do anything possible to simplify your expression. So now we have a 3 minus x over root 3 minus root x. Simplifying this, what am I going to have? Now, either method you use, it will be very much correct. Either of the method you use, it will still be very much correct, because this is a what? Someone would decide to rationalize the denominator, someone would decide to use the concept of difference of two squares. All would be the same thing as moles. So if I have 3 minus x over root of 3, so let's try to simplify the inside part. So I'm going to have 3 minus x over root 3 minus root x. This can be broken down to rationalizing. That would be, if I multiply this by the conjugate, this would be root 3 plus root x over root 3 plus root x, rationalizing the denominator, so that this can end up to be, this times that to be 3 minus x and root 3 plus root x over the denominator. This is the difference of two squares. This squared to be 3, this squared to be x. I'm going to have something like this, so that this and this can go, and I'll remain with root 3 plus root x. So instead of using this guy here, we are going to use the simplified version, which is this. That's what we mean by simplify your function. So if it brings it 0 over 0, mean that this is not the right function you are going to use when finding the limits. It means proceed and factorize or rationalize or simplify it further. So this always works when it comes to the limit at a point. So we factorized or we rationalized. So now let's replace this guy back in this instead of using this guy. So we're now going to have, let me delete this part. So this means that we are now working with the limit as x approaches 3 of the natural log of root of 3 plus root of x. So if I put back the 3 there, this would be the natural log of limit as x approaches 3 of root of 3 plus root of x. So that evaluating it at 3, we are going to have the natural log of root of 3 plus root of 3. Close. So root of 3 plus root of 3, how many root 3's do I have here? I have 2 of them. So this will be the natural log of 2 root 3 as my final solution. So what is happening here, when x approaches 3 in this function, the whole given function will basically approach 2 over 3. So as we draw nearer and nearer to 3, the whole function will draw nearer and nearer to 2 root 3. That's what we have. Okay, now let's look at the next one, C. Let's look at the next one, C. So C says that evaluate the limit t approaches 5 of t minus 5 over 2 minus root t minus 1. So what is the limit as t approaches 5? As usual, if I evaluate, what am I going to have? This will be t minus 5 over 2 minus, am I correct? So t is 5. So this will be 5 minus 5 over 5 minus 1. This will be equal to 0 in the numerator. This is a 4 root of 4 to be 2 to be 0 in the denominator. And this is an indeterminate form of limits. So it should never be part of my solution. So it means I have to do something to my function. So rationalizing the function, what am I going to have? Since it has a radical, that is what I'm going to rationalize. So rationalizing the function, I'm going to have t minus 5 over 2 minus root t minus 1. So that this becomes multiplying both sides by the conjugate to be 2 plus root t minus 1 and 2 plus root t minus 1. So that after rationalizing, I'm going to have something like, this is a t minus 5, 2 plus root of t minus 1 over, this is a difference of 2 squares, so this will be 2 squared minus t minus 1 squared, sorry, t minus 1, since the root has gone. So that we can have, so this will be t minus 5 root t plus root t minus 1. Close, and in the denominator this is a 4 minus t plus 1. So this becomes t minus 5, 2 plus root of t minus 1 over this plus that is 5 minus t. This is what we're going to have. Now, we've seen that in the numerator there's t minus 5 and in the denominator there's 5 minus t. These two are not the same, but we can basically make them to be the same. How are these two similar? We have to understand that t minus 5 is equal to the negative of 5 minus a t. We are okay? So how is the t minus 5 going to be formed? Or how is the negative 5 minus t going to be formed? In the t minus 5, we can factor out a negative. So if I factor out a negative, t will be negative and 5 will be positive. So factoring out a negative here, negative 1 comes out, negative t plus 5. So that is why I'm simply saying this is equivalent to that. So that when we replace it there, I'm going to have negative of 5 minus t, 2 plus root of t minus 1, close over 5 minus t. So that this guy and this guy can go, and then I'll remain with a negative of 2 plus root of t minus 1 as in my function. Now, remember we were just trying to rationalize the function there so that it should not become an indeterminate form. So this is our f of x, which we are going to replace back. Our f of t, which we are now going to place back here. So instead of using this guy, we'll use this guy, because we don't want an e in determinant form, a 0/0 expression. So let's take it back. So I'm now going to have the limit as t approaches 5 of -2 plus root of t minus 1 close. So that when you evaluate, this will be -2 plus 5 minus 1 close. This will be -2 plus 4, something like that, so that we can have, so this is the root 4, and then root 4 is 2 plus 2 is 2 plus 2 is what? A 4, and there's a negative outside, so this is -4 as our solution. So as t approaches 5 in this function, the whole function will basically approach what? Approach -4. There. We are okay. So the same is happening on D. The same is happening on D, E, and F. The same is happening on D, E, and F. Okay, so maybe let me try to work out one, and then the rest of those two will be your task. So let me choose one. Which one can I choose? Which one is the simplest? So I have that D, the limit as x approaches 1 of the root of x plus 3 minus 2 over x minus 1. So if I evaluate, if I put a 1 there, this will be root of 1 plus 3 minus 2 over 1 minus 1, which will be equivalent to what? This will be root 4 minus 2, which will be 2 minus 2 over 1 minus 1, which will be equal to a 0/0, which is an indeterminate form. This should not be your solution. So what should I do? Rationalize that, since it has a radical. So rationalizing it, what am I going to have? I'm going to have multiply both by the conjugates of the numerator, since this time the radical is in the numerator, so I'm going to multiply by the conjugate of the numerator. So that this is a difference of 2 squares by default. So this will become x plus 3 minus 4 over this, and this becomes x minus 1 and x plus 3 plus 2, so that we can have this, and that is -1 to be x minus 1 over x minus 1 root of x plus 3 plus 2, so that this and this can go, and we're going to have 1 over root of x plus 3 plus 2, something like that. We're okay. So instead of using this guy, we'll use this one. So on that part, we're going to have the limit as x approaches 1 of root of x plus 3 plus 2, so that this becomes, put a 1 there to be root of 1 plus 3 plus 2, which will be 2 plus 2, which will be equal to a 4. As simple as that. Everything. So the same is happening with E. The same is happening with E. A hint on E if you look at E and you are looking for the limit as x approaches -1 of that function, or let me just delete this part. If you look at E, where you're looking for the limit as x approaches -1 of that function is given by x squared minus x minus 2 over x power 3 minus x. If you put in -1 the way it is here, you will discover that what is going to happen, it will be a 0 over 0 function, and it is an indeterminate form. So that should not be your solution. It means that you have to factorize complete. So the only way you can do with this one is factorizing completely. By factorizing complete, it means that both functions should be factorized complete. Factorize this one. This is a quadratic. I'm sure some product and factors work out with that one. This is also something you can factorize. Common thing is x outside. Once you factorize both the numerator and the denominator, you can cancel out the common thing in both the numerator and denominator. Then the function you're going to have there to be a simplified function, and now be able to punch in the limit as x approaches -1. Okay, so with that done, that is the first part on limits. Limits at a point. So the next video will just contain limits at infinity. The next video will contain limits at infinity. Yeah. Okay, let's look at that graph. Let's look at the graph there in our worksheet. I'm sure the graph is visible there. What is happening, and then what are we trying to find? What is happening, and then what are we trying to find? So in the graph there, remember, when understanding the concept of limits, we have to be able to understand that limits is just a matter of knowing the concept of what are you approaching and what is the whole graph going to approach. What are you approaching and what is the whole graph going to approach? So this is question number, what question number is this of the worksheet? Question number 6 of that worksheet, which involves graphs. So we want to find certain particular points using the graph indicated there. So let's look at the first one. The first one says that find the limit. Are we able to find the limit as x approaches -1 of f of x? -1 of f of x. Now, actually it's not just -1. There is a, we are trying to find the limit as x approaches -1, and there's a negative on top here. So the negative on top here means that we are trying to approach -1 from the left direction. The positive x approaches -1, positive on top. This means that we are trying to approach -1 from the right direction. We are okay? So now, if I am approaching -1 from the left direction, the answer I'm going to have, if it is equal to the answer I'm going to have when I'm approaching x from the positive direction, if these two are the same answers, then the general limit as x approaches -1 of f of x, it will exist. But if these two values are different, then the limit as x approaches -1 of f of x will not exist. So the limit at a certain particular point will only exist if the left limit and the right limit are the same. So we have to understand that the general limit, the general limit will exist if the left limit is equal to the right limit. So this is the left limit because it has a negative on top. This is the right limit because it has a positive on top. And this is the general limit. It doesn't have anything on top. So anything we had any symbol on top of that point, then the limit is a general limit. If it has a negative on top, it is a left limit. If it has a positive on top, it is a right limit. So the indication there is that begin to approach that particular point from the left side if it has a negative. So stand at -1 on the graph. So look at -1 on your graph. This is my -1. According to the screen here, you can see that this is my -1. So now, if you stand at -1 here, this line here is a line x equal to -1. This straight line here. So if that is the line x equal to -1, what is going to happen? If that is the line x equal to -1, what is going to happen? We are looking at approaching this -1 from the left. So from the left, it means that the left side is this part, and the right side is this part. We are okay? So now we're trying to approach -1 from the left. So the left part, it is this part. So it means that it is this graph we're trying to approach. So I'm going to use the rod for the left graph. So the left graph here, it is this graph. So I'm going to use it, trying to draw closer to the line x equal to -1. So draw a line at x equal to -1. So this is a graph which is in this format. There is a -1 there, and there is a graph which is coming in this direction. So you draw a line, either vertical or dotted or what. Draw a line at x equal to -1 and use a graph to approach this line. So if it will touch that line, the point where it is going to touch the line, that will be the limit. So if let's say this graph was coming Ukuka, I'm trying to approach -1 from this direction. So if let's say it touched the line x equal to -1 at this particular point, if the touching was at this particular point where it's touching the line, then the limit would have been this y value. Let's say if this y value was -4, then the limit would have been -4. But now let's look at that graph. That graph in your worksheet has this graph drawing closer to -1, but it is not attaching, it is just coming down. What does this insinuate? If you are trying to approach -1 line here, x equal to -1, the graph is just getting attracted to x equal to -1, but going down. It means as x approaches -1, the whole graph f of x will approach what? -infinity. Because this down here, I'm going to have a -infinity value. The y value here, as I go down, it's something which is a negative. So the left limit of -1 means that the whole graph is coming down here. It does not approach, or it does not touch this line. It means that the whole graph basically approach what? -infinity. That's what we have. But if we are simply saying that locate the limit as x equal to -1, as x approaches -1 of the right side. The right side means if this is the line x equal to -1, this is my line x equal to -1. The right side means should be the graph on my right side. The right side should be a graph on my right side. And the right side there, it is this graph, which is moving in that direction until it touches there. So you follow this route, coming down there, getting attracted to the what? To the line x equal to -1. And this graph is coming to end here, where it is open there as above. That's where it's going to end from. So this indicates that our limit, if I'm coming from the right direction, the whole graph is getting attracted, or is going to touch the y value at this particular point. So when x is equal to -1, using this graph, the value of y is going to be equal to what? Is equal to 0 at this particular point. So this is -1, 0. But this graph left, it was not touching the x equal to -1 line. So no one, it was just coming down, it was equal to -infinity. But this graph, it is getting attracted to x equal to -1 and stops there. And when it is stopping there, it is -1, 0. So it means from the right direction, what am I going to have? The limit here, it is at what? 0. So when x approaches -1, the whole function approaches 0. So this is the left limit, this is the right limit. Now if the left and the right limit have two different values, then the general limit, the one doesn't have a negative or a positive. The general limit does not what? This one does not exist. That's what we have. So that one will not exist. We are okay? Now let's look at the other part. The other part is as x approaches 0, the limit as x approaches 0 from the left direction, there's a negative on top of f of x. After we find that, we want to find the limit as x approaches 0 from the right direction, there's a positive on top. After you do that, find the general limit now. Limit as x approaches 0 of f of x. The left limit has a power negative. The right limit has a power of positive. And the general limit has just itself, just a number as itself. So this general limit can only exist if the left limit and the right limit are the same. So x should be equal to 0. So in your graph there, where is x equal to 0? It is at this point. Draw a line at x equal to 0. This line, qua. Sorry, x equal to 0 is this line, qua. X equal to 0. So we are going to use that line to evaluate the left and the right limit. So if you, this is your Cartesian plane, if you look at your graph very careful, x equal to 0 is at this point. This is the line we're talking about. So if you stand at this same line, use the left graph and the right graph to approach 0. So now draw a line at x equal to 0. And at x equal to 0, what reference graphs are we going to have? There is this particular graph which is moving like this. This is what we have. So that graph, it is the one which is demarcating. So if I draw a line, x equal to 0, it is cutting this graph at this particular point. So there is this curve on my right side, and there is this curve on my left side. It's the one I'm using. So if I'm approaching x equal to 0 on the left side, it is this graph I'm using. If I'm approaching x equal to 0 on my right side, it is this curve I'm using. So now, left side, this curve, it is getting x equal to 0. Where is it going to lead to? It is going to stop at this point. And what is the value of y at this point? The value of y at that point, it is what? -1. This is at -1. So from the left side, the whole function is equal to -1. From the right side, it is coming, getting attracted to that line. It is still at this particular point, -1. This is equal to what? -1. The left limit is equal to -1. The right limit is equal to -1. The general limit will exist. It will equal to what? -1. But the previous one, the left limit was -infinity, and that one was a 0. There were different values. No wonder the general limit didn't exist. This one, the general limit will exist, which is equal to what? -1. We are okay? So that is the limits which we're talking about. Those are the limits. The same is happening if you wanted to find f of 1, if you wanted to find f of 1, 1 is here. So if you draw a line at f of 1 here, as the limit as x equal to 1, as x approaches 1 is at this particular point. So evaluating, so now there's a different, look at this is the limit as x equal to 0, as x approaches 0 from the left side, as x approaches 0 from the positive side, and the general limit as x approaches 0. So these three are limits. But if I say f of 0, this is an evaluation. What is the value of f of x if x is 0? This particular point, it is still equal to -1. But the previous one, I think we didn't find f of -1. F of -1 was here. This is an open cycle. So at this particular point here, what is f of -1? F of -1 at this particular point, you draw your line here at x equal to -1. Your value here, the valuation here, it should be a point which is continuous or shaded. Here it is not shaded. It means that this is not the evaluation of f of -1. So the evaluation, it is here at that particular point here, which is shaded here at this particular point here, which is at what? At 2. Isn't it? Yeah. So it means that f of -2 will be at 2. But the limit as x approaches -2, we had the one which was coming from the left direction, and we had the one which was coming from the right direction. By the evaluation, it is that particular dot here, which is defined when x equals to -1. And lastly, but not the least, when we have the limit as x approaches 1 of f of x, 1 is this particular point. The left direction and the right direction should exist for me to find the limit as x approaches 1. So for the general limit as x approaches 1 to work out, I need to find the limit as x approaches 1 from the left direction. I need to find the limit as x approaches 1 from the right direction. So general limit exists. I need to have the left limit from the negative. This is x equal to 1, this line. So the curve from the left, it is this curve. It is drawing closer to that line, it will stop at this particular point. It is x equal to what? I mean the y equal to what? 0. This one coming down, stops there. It is equal to what? 0. It means that the general limit as well will be equal to what? Will be equal to 0. Evaluation, f of 1. F of 1 at this particular point, this curve is continuous here. It's not open. If it was open like this, if it was open here, then the evaluation could not have been 0. But since it is continuously moving like that, the evaluation is equal to what? Is also equal to 0. That's what we have. So with that done, be able just to work out the task I gave out. Question number 2, finish the questions finish the questions D, A, and F. And question number 3, do A, C, and H. Thank you very much, and see you in our next meeting.